Question 37 says, determine the coordinates of the corners of the rectangles to compute the area of the rectangle using the distance formula. Round to the nearest integer. Alright, so we got a couple things going on here. First of all, the area of a rectangle is length times width. So we're going to have to find the distance of the length. And then we're going to have to find the distance of the width. And we're going to have to multiply those two things together. All right, it also says to determine the coordinates of the corners. So I need to go ahead and come up with the coordinates of each of these corner pieces. Now I'm not going to find the coordinate of this last one because I don't need it to find my length or my width. So I'm just going to use the ones that I need. So it looks like this one is at 1, 8. This coordinate looks like it's at 4, 5. And remember, coordinates are always x value first and then y value. This is the x-axis, this is the y-axis. So to get this one, we would go down to the x-axis first, which is at 17. And then we would go over to the y-axis, which is at 18. Alright, so we've labeled the corners. And then it says to use the distance formula. So I pulled this straight from the formula sheet. You don't have to have this memorized. So we're going to go ahead and use this to find the distance. So I'm going to find the distance of the green line first. So I'm going to let this ordered pair be x1 and y1. And I'm going to let this one be x2 and y2. And then I'm going to plug it in. So my x2 is 17 minus my x1, which is 4. My y2 is 18 minus my y1, which is 5. And then I'm going to go to my calculator and I'm going to plug that in. So if you have a TI-30XS, you can plug it in exactly how it looks all in one step. So you could do 17 minus 4, close your parentheses and square it, plus, parentheses, 18 minus 5, close your parentheses and square it, and hit enter. And that tells us that the distance is 13 square root of 2, or approximately, let me pull it back up. To get the approximate, you would hit the double arrow. It's approximately 18.38. Alright, so that is the distance of the green line. Now I'm going to go and I'm going to find the distance of the yellow. So we're going to use this same distance formula. Since I already have this ordered pair labeled as x1, y1, I'm going to label this one x2, y2. And then I'm going to plug it into my distance formula. So x2 minus x1, and it doesn't matter which point you let be x2 and which point you let be x1. As long as you stay consistent. Okay, so this time, instead of typing it all in one step, I'm going to show you what you would do if you didn't have a calculator like this that you could type it all in. So you could just do 1 minus 4 and then square that number. So take negative 3 and square it, or you could do negative 3 times negative 3. So I would start off this first piece right here would be 9. And then I would go to the other one. And I would do 8 minus 5. And then I would take that number and square it. If you want, you could either type in 3 squared, or you could type in 3 times 3. This one is also 9. And then you could go to your calculator and you could add 9 plus 9 is 18. So this one would equal the square root of 18. If you wanted to get an approximation for that, you could type that in, square root of 18, and then hit the double arrow. So this one is approximately 4.24. And then we're looking for area, so we need to do length times width. Well, first let me just color code this so you can remember. This was the yellow distance. All right, so now we're going to come down here and we're going to do length times width. So I'm going to leave it as 13 square roots of 2 times the square root of 18, just so I don't have any rounding errors. So I'm going to do 13 square roots of 2 times the square root of 18. And I got 78. Now if you did round, if you used 18.38 times 4.24, you would get close enough to know that it was going to be the same answer. It was going to be 78. So our area here is 78 units.